Hello again. Welcome back to the Wish Tech channel, the Clean Air channel. Today we're going to continue our discussion on climate change and global warming. I entitled this "The Truth About Climate Change." So what we're going to do first is look at the Earth's atmosphere as a closed system. I have a demonstration for you that helps illustrate a closed system. We're in a bubble. We're in a closed bubble that's around the Earth. We're burning fossil fuels. Fossil fuels takes oxygen out of the atmosphere. That oxygen we cannot use to breathe once it's combined and tied up with carbon dioxide. That's what's going on inside the bubble. Then we have the compounding effect of wildfires that's taking more oxygen out of the atmosphere, generating more CO2 and generating more water vapor. We're going to see that. And then we're going to look lastly at these direct CO2 capture plants. These plants are being touted as the solution to our emissions problems, and I'm here to tell you, don't hold your breath. They're not going to work, and I'm going to show you why. Matter of fact, they may be of everything, they may be the big hoax, because I've never seen one of these plants. Have anybody seen one of these direct capture plants? You'll see why I say they may be the hoax here in a minute as we progress through this truth about climate change. Right now we're looking at this candle jar. It is an open system. We have a flame. It has the three elements for a fire. It has heat, it has fuel, and it has oxygen. We're going to take the oxygen away because we're going to change it to a closed system. And when we do, with that flame in there, it's going to deplete the oxygen inside of the candle until it can no longer support the flame, and then the candle will go out. So we've snuffed out the candle. Here we go. Here's what happens when you burn fossil fuels. Qualitatively, here's what happens. Here the fossil fuel, oxygen, a spark, the three elements for a fire. You got all three of these guys, you can have a fire. And once you overcome the activation energy, this reaction is exothermic. It really runs downhill this direction. Boom. And you generate a lot of heat here, okay, from this fossil fuel burning. You make a whole lot of heat. That's why we use fossil fuels, gas, coal, and crude oil, because it's got a lot of heat and value that's in it. So that's what's warming up the planet, people. It's not the CO2. CO2 is a byproduct, and so is water vapor. We put a lot of water vapor up there. It's actually water in the gas form. It's steam. And this right here is getting into the atmosphere, and it condenses. It causes flooding. Atmospheric rivers, we've seen those in some areas of the country. So CO2 is not the culprit. Now I can explain it better like this. Take your car. You drive your car. The engine's hot, you pull it in the garage, cut your engine off, so you're not making any more CO2. You go in the house, come back a half hour later, the garage is hot. Why? That's the heat that came from the fossil fuel. You just can't ignore it. It goes into the environment and it heats the environment up. It's not the CO2. Okay? Oil doesn't want you to know that. Okay? So they tell you it's climate change is causing the planet temperature to go up. And what's causing climate change is CO2 Greenhouse Effect, okay? So fossil fuels are 2 levels removed from global warming by design. It was a branding campaign by Big Oil to disconnect fossil fuels from what was going on in the environment. The warming of the planet from the heat of reaction that's generated when you burn fossil fuels, that itself is not a threat to the humans. However, it is a problem for the polar bears who live in the Arctic because ice sheets have melted and you can find the polar bear floating around on broken ice sheets with no food. So they're there waiting to die by starvation. So, the planet warming up is not a big deal for us from a survival standpoint. Okay, but what is a big deal for us is that we're inside a closed system. I call it the Earth's bubble. We're inside the bubble. Here's the atmosphere. It's only 10 miles thick. This air, this thin air layer that's around the globe. It's only 10 miles thick. We think it's infinite, but it's not. Okay, and inside is where we're depleting oxygen. We take fossil fuel is where the carbon comes from. We take oxygen that's in the air. We combine the carbon with the oxygen. We have a kid, his name is carbon dioxide. He doesn't look anything like his mother. He doesn't act anything like his mother or his father. He may look similar to both, but he has different characteristics. In other words, this is oxygen here, but we can't use it. Our bodies can't use it because it's attached to this carbon. So that's what's going on inside the bubble. We're converting carbon dioxide. We're converting oxygen to carbon dioxide by burning massive amounts of fossil fuel. And it's warming the planet up. So if what I'm telling you is true, we should be able to look at the oxygen concentration in the atmosphere and the O2 concentration should be dropping, right? That's what I'm telling you is true. And of course, this is what we see. We see here, this is oxygen concentration over time, this direction. And you can see the O2 concentration, what is it doing? It's falling, it's dropping over time because we are using oxygen faster than we are making it. What's supposed to make the oxygen? Of course, the trees, they capture CO2 and they in turn turn the CO2 back to oxygen. So here we are, human being, we're taking in oxygen, we're exhaling carbon dioxide. The trees need carbon dioxide, they're taking the carbon dioxide in, they use it, and they put out O2. So we have a nice balance here. We have a circle of life going on, a kumbaya moment between man and greenery on the planet, between CO2 and O2. And it should be balanced, but it's not balanced because we're burning up our trees. Our trees are on fire because the global temperature is up. Here's the Amazon rainforest. It is burning. And when you start burning the forest, similar to fossil fuels, he produces a lot of heat. That's driving the temperature of the planet up. We produce CO2, which if greenhouse gas is a big effect, then we're making more CO2 because we're burning fossil fuels. And then we have water vapor again generated. Just like we're burning fossil fuels, we just change and put forest in the equation. And we got indoor air quality problems from the burning of the forest. We have heat that's added to the environment. We decrease the O2 in the atmosphere, and we're losing millions of trees, the very thing that we need to be able to sustain life on this planet. By changing carbon dioxide back to oxygen, we're losing those. Okay, we're losing those to wildfires. This diagram is produced by NASA. It shows on May 27, 2024. It shows the number of fires there in Canada and on the West Coast. And you can see that the North America is on fire. This is not an uncommon thing. It's fires from here to Australia. The whole globe is on fire, pretty much. Okay. So we have not enough trees, and the way you know there's not enough trees is simple. The CO2. Here's CO2 on the y-axis, time on the x. The CO2 is steadily increasing because you don't have enough trees your forest system is degraded. About 80% of our forest on the planet is gone. 80% of it is gone. Okay. So that means that fossil fuels are a non-sustainable form of energy versus wind turbines or solar that is sustainable. Non-sustainable. As time goes to infinity, we go to zero. That's not sustainable. Okay, we need renewable energy. We need sustainable energy, something that we can continue to do forever. Okay, that's the goal. Now, the direct capture CO2 plants are being touted as a solution to our emissions. If they can get them to work, they've been having a little problem with them. It worked in the laboratory, but on a commercial scale out in the field, they're having a little trouble with these guys. The recovery of CO2 is low. The energy cost is real high on these guys. But they're still working around the planet on them. There are about 17 of these guys around the planet. Now, I'll just tell you right now, I don't think they're going to work because it's very hard to make a cut of you've got 200 part per million of something. That's a very small amount, 200 parts per million. It's a lot easier to take something that's like 2% out of another substance. But when you start talking about part per million, God does it real nicely with trees. He can take that CO2 out of massive amounts of air using trees. But man, we're having a hard time doing it. Okay, so the other problem with this, the direct capture plants, given their size, we would need 11 million of these direct capture plants to calibrate you. We have about 700 oil refineries on the planet. 700 oil refineries. Here we need 11 million CO2 plants. It's not technically feasible that we can process the entire Earth's atmosphere and remove CO2 with these plants. It's just not going to happen. So today it's the polar bear that's extinct because the polar caps are now melting, something that Exxon said in 1982 that they did not want to do, but yet you look up and they've done it. The polar bear is fighting for existence. And his problem is global warming. That's not our problem. Our problem, we could be next because our problem is depletion of oxygen inside the closed system, which is our Earth's atmosphere. So we looked at the Earth as a closed system. You saw the demonstration where we snuffed out the candle. It was lack of oxygen. We talked about burning the fossil fuels, how it produces heat. It's the actual heat that's raising the temperature of the planet. It's not CO2. It's not climate change. We talked also about the forest fires, the wildfires, and how they further deplete the oxygen. The CO2 capture plants are not going to be the thing that saves us because they don't regenerate oxygen like the trees do. So our solution could very well be reducing the use of fossil fuels, maybe. Because when you burn fossil fuels, you make a direct amount of heat. The heat that's generated is directly proportional to the amount of fossil fuels you burn. You move your fossil fuel consumption up, your heat that you put into the atmosphere goes up. You bring it down, it comes back down. So that's really the only button that we have to turn to control global warming. So that's all I have for you for right now, but I thank you so much for tuning in and listening to the Rich Tech Clean Air channel, and we'll see you next time. Thank you for listening.